Hello and welcome to this video from Heybridge High School Maths Department, and today we're going to look at the first section of Unit SP5, which is SP5.1 Thinking Logically. So we've got a simple logic problem here. So we've got Rana, Tony and Millie and their sisters, and we have to deduce, so we have to work out which sister is 9 years old, which one is 12 and which one is 14. So we've got a table here that we can use to solve the problem, and this is called a logic table. So let's put Rana, Tony and Millie along the top, and let's put their ages down the side. So one is 9, one is 12 and one is 14. And then we're given some clues. So if we can work out from the clues that something is true, we're going to put a tick in the relevant box. And if we can work out from the clues that something is false, we're going to put cross in the box. So first of all, Tony's age is not in the 4 times table. So we now need to look at our 3 ages. So 9 isn't in the 4 times table. And it says Tony's age is not in the 4 times table. So Tony could be 9. She can't be 12 because 12 is in the 4 times table and her age isn't. She could also be 14 because 14 is not in the 4 times table. So we now have a look at our second clue. Millie's age can be divided exactly by the number of days in a week. So the number of days in a week is 7. And out of our 3 ages, the only number that can be divided exactly by 7 is 14. So because 14 divided by 7 is 2. So we know that Millie is 14. So we can put a tick in that box. We can then say we know that Millie isn't 12 and she isn't 9 because we know that she's 14. So we're going to put crosses in those boxes. We can also say that because Millie is 14, Tony can't be 14 and Rana can't be 14 either. And that then helps us to solve the puzzle. So Tony's got to be 9 because she can't be 14 because Millie is 14, and she can't be 12 because it's in the 4 times table and her age is not in the 4 times table. Because Tony's 9, we've already said here that Millie isn't 9, and we can also now say that Rana isn't 9. So that leaves Rana as being 12. So we've worked out that Rana is 12, Tony is 9, and Millie is 14. And that's what logic's all about. It's about using what you know to make deductions so that you can reach conclusions. And a lot of mathematics is based. So we've now got a slightly more complicated problem. So we've got 4 houses and they're numbered 1, 2, 3 or 4. And we've got 4 people that live in the houses in Baker's Row: Ted, Alice, Ernie and Geeta. So let's put Ted, Alice, Ernie and Geeta on the side, and along the top let's put our house numbers 1, 2, 3 and 4. And then I'm going to use the 4 clues to work out who lives in which house. So the number of Ted's house is an even number. So even numbers, I can divide them by 2. So Ted can't live in number 1 and he can't live in number 3. Clue number 2 says the number of Ernie's house is an odd number. So that means that Ernie can't live in a house whose number is even, so is divisible by 2. So Ernie can't live in number 2 and he can't live in number 4. The number of Alice's house is greater than the number of Ted's house. So that means that the number of the house where Alice lives has to be bigger than the number of the house where Ted lives. So Alice can't live in number 1 because that's the smallest number. So she couldn't possibly live there because that isn't bigger. That couldn't be bigger than the number of Ted's house. We also know that Ted doesn't live in house number 1. So Alice can't live in house number 2 either, because number 2 isn't bigger than the number of a house that Ted could live in, because Ted can't live in house number 1. And then if we have a look at Ted, Ted couldn't live in number 4, because if the number of Alice's house has got to be bigger than the number of Ted's house, Ted can't live in the house with the highest number. So that now tells us that Ted lives at number 2, because that's the only option left. So we've worked out then that Ted lives at number 2. And then we're also told the number of Geeta's house is less than the number of Ernie's house. Well, if it's going to be less, then Geeta can't live in number 4, because that's the biggest number. So Ernie couldn't live in a house. Sorry, Geeta couldn't live in a house that had a smaller number than Ernie's. That then has told us that Ted, Ernie and Geeta cannot live in number 4. So Alice must live in number 4. So we've now deduced that Alice lives in number 4. Now, if the number of Geeta's house is less than the number of Ernie's house, Ernie can't live in number 1, because there isn't a house with a number smaller than 1. That means that Geeta must live in house number 1, and that leaves Ernie living in house number 3. So Ernie lives in house number 3, and Geeta lives in house number 1. So something that we quite often solve in statistics are two-way tables, and we have to use logic to solve two-way tables. So we've got a table here, and it tells us that Emma collected information about the cats and dogs that children in her class have. She filled in the table below, but missed out one number. And then question A, if there are 30 children in Emma's class, what is the missing number? So there are 30 children altogether, so we need to know how many children she's already put into the table. So we're going to add together the numbers in the table. We're going to do 8 add 4 add 12, and that will give us 24. And there are 30 children in her class altogether, so we need to find out how many are left. So 30 take away 24 is 6. So the missing number in the table is 6. Now question B, how many children own at least one of these pets? So at least one means they either have a cat, they have a dog, or they could have a cat and a dog. They've got to have at least one, but they could have more. And that's going to be everyone that we added up in the first question. So again, it's going to be 8, because 8 of them have a dog and a cat. It's going to be 4, add 4, because 4 of them only have a cat. And then we're also going to add the 12 that only have a dog, and that will give us 24. So question C, do more children own cats rather than dogs? So we need to work across. So these are all the people that have a cat. So 12 people have a cat. Everyone that's in that row has got a cat. Everyone that's in this column has got a dog. So do more children own cats rather than dogs? No, because only 12 children own a cat, whereas 20 children own a dog. D, could it be true that some of the children do not have any pets? So we've got 6 children here that don't have a dog or a cat. Now, cats and dogs obviously are not the only pets you can have. They could have other pets. They might have a horse, a rabbit, a mouse, some other pet. So yes, it could be true. This only tells us about dogs and cats, but it could be true that some of these children don't have any other pets either. So now we're going to complete a two-way table. It's a good idea to put yourself some little headings on to show you that at the bottom you'll have the totals. So in Ben's class there are 12 girls and 18 boys. So I've got 18 boys and 12 girls. Be really careful that you get the information in the correct column. This question says 12 girls and 18 boys, but in the table the boys come before the girls. So just check that you have got the right information in the right place. So altogether we're going to have 18 plus 12 equals 30 children in Ben's class. There are 6 children who bring packed lunches and the rest eat school lunches. So 6 children bring a packed lunch. There are 30 children altogether. So I can work out how many have a school lunch by subtracting the 6 who have a packed lunch from the 30 in the class altogether. That's going to leave me with 24. Now it says Ben and Adam are the only boys who bring packed lunches. So that means there are only 2 boys that bring packed lunches. Altogether 6 children bring a packed lunch. So 6 children minus the 2 boys will give us the 4 girls that bring packed lunches. Then we can work down the columns to work out how many boys and how many girls eat school lunches. So there are 18 boys altogether, 2 of them eat packed lunches, so 16 of them must eat a school lunch. And similarly there are 12 girls altogether, 4 of them bring a packed lunch, so 8 of them must eat a school lunch. Now that we've completed the table, we can answer the questions. How many children are there in the class? So this is this box here. It's the total of packed lunches and school lunches. It's also the total of boys and girls. So altogether there are 30 children in the class. How many girls eat school lunches? So we're going to find girls. We're going to go down until we get to school lunches, and we can see that 8 girls eat school lunches. Sudoku puzzles have become very popular, and they originated in Japan, and they're really good for developing your logic skills. I'm now going to go through a couple of simple Sudoku puzzles with you. So the rule for this Sudoku is that the numbers 1 to 4 have to appear in every 2x2 box, in every row and in every column. So if I have a look at my first box, I've already got 1, 2 and 4 in there, so I know that I'm going to have a 3 there. I've already got 1, 2 and 3 in this box, so I've got to have a 4 in there. And I've already got 2, 3 and 4 in this box, so I've got to have a 1 in here. Now if I have a look at these 2 columns, I've got 4, 2 and 3 there, so I've got to have a 1 there, and I can check by looking across my row. So I've got 2, 4, 1 and 3. So yes, I've got all 4 digits in there. And again, if I have a look down this row, I've got 3, 1 and 4, so 2 should go in here. And if I check across my row, I've got 3, 1, 4 and 2. So the Sudoku is now complete. So finally, we're going to have a look at this logic problem, which involves symbols. So we've got 4 symbols, and we're told what some of the rows and columns are worth. So if we have a look at the top here, the red question mark, the pink pennant, the blue cross and the orange, it kind of looks like a B, are worth 29. I need to find something where all 4 of them are the same to be able to work out what the symbol's worth. So I'm going to look here. So I've got 4 pink pennants. So I know that 4 of that shape are worth 48. So therefore each one will be worth 48 divided by 4, which will give me 12. So each one of these pink shapes is worth 12. Let's just write those in the boxes. So I'm now going to look for a row that is just the pink pennant and one other shape. So I'm going to go, so I could choose the orange bee, but I don't know how much that row's worth. So I'm going to pick the red question mark. And altogether 3 red question marks plus 1 pink pennant are worth 33. So that means that 3 of those red question marks plus 12 are worth 33. So if I subtract 12 from both sides, I'm going to get that 3 red question marks are worth 21. So one of them will be worth 21 divided by 3, which is equal to 7. So I can now mark those in. So now I want another one. So now I want a red question mark, a pink pennant, and one other symbol. So if I have a look at this row going down here, I've only got blue cross, pink pennant, and red question mark. So 2 blue crosses plus 1 pink pennant's worth 12, plus 1 red question mark is worth 7, and altogether that's going to give me 31. So 2 of those plus 19 is equal to 31. So 2 of those is equal to 31. Take away 19, which is 12. So 1 will be equal to 12 divided by 2, which is 6. So now I'm going to mark all of those as worth 6. Now, if I have a look across here, that whole row is worth 29. So I now need to work out what this little sort of bee-shaped thing is worth, the little orange shape. So that, add 7, add 12, add 6 is equal to 29. So let's add my numbers up. 7 add 12 is 19. 19 add 6 is 29. So one of my little orange bee shapes will be worth, plus 25 will be worth 29. So if I subtract 25 from both sides, one of these will be worth 4. So all I'm going to do now is I'm going to add across this row with the question mark at the end. So I'm going to do 4, add 12, add 4, add 12, and that will give me 32. Thank you for watching.